Welcome to aminacademy.com. In astronomy, let us discuss about formation of the solar system. The sun and the planets formed together 4.6 billion years ago from a cloud of gas and dust called the solar nebula. A shock wave from a nearby supernova explosion probably initiated the collapse of the solar nebulas. The sun formed in the center and the planets formed in a thin disk orbiting around it. In a similar manner, moons formed orbiting the gas giant planets. Comets condensed in the outer solar system, and many of them were thrown out to great distances by close gravitational encounters with the giant planets. After the sun ignited, a strong solar wind cleared the system of a gas and dust. The asteroids represent the rocky debris that remained. Size and time scales of the solar system. The Earth revolves around the Sun at a distance of 150 million kilometers. The orbits of the planets are nearly circular and measure from one third to 30 times the size of Earth's orbit. Mercury, the innermost planet, orbits the Sun in about 3 months, while Neptune takes 165 years. The Sun contains about 99.9% of all the mass of the solar system. Now let us discuss further detail about the formation of the solar system. The solar system formed approximately 4.6 billion years ago from a collapsing cloud of gas and dust called the solar nebula. This collapse This collapse, possibly triggered by a supernova's shock wave, led to the formation of a spinning disk with the sun at the center of and planets forming in the surrounding disk. The process involved accretion, where the particles in the disk collided and stuck together to form larger bodies, eventually leading to the planets as we see today. What is initial nebula? The solar system began as a vast rotating cloud of gas and dust, primarily hydrogen and helium, with traces of heavier elements. The formation of our solar system began approximately 4.6 billion years ago with a vast spinning cloud of gas and dust known as a solar nebula. Gravity caused this nebula to collapse, possibly triggered by a shock wave from a nearby supernova, leading to the formation of central dense protostar, which would become our sun, and a flattened, swirling accretion disk of material around it. Collapse and flattening. Gravity caused the nebula to collapse, and as it contracted, it began to spin faster, flattening into a disk shape due to conservation of angular momentum. The solar system formed approximately 4.6 billion years ago from the gravitational collapse and consequent flattening of a vast cloud of gas and dust known as the solar nebula, likely triggered by a nearby supernova shock wave. As the nebula collapsed under its own gravity, conservation of angular momentum caused it to spin faster and flatten into a spinning protoplanetary disk with a dense, hot protostar as its center, which could become the sun. Protostar formation. The majority of the material in the nebula concentrated in the center, forming a dense hot protostar, which eventually ignited to become the sun, although nuclear fusion. Protostar formation is the initial stage of stellar evolution where a dense clump within a giant molecular cloud collapses under its own gravity, heats up, and becoming a self-luminous developing star that has not yet achieved nuclear fusion. This process is a key component of the nebular hypothesis for the formation of our solar system, which began about 4.6 billion years ago with the gravitational collapse of a giant molecular cloud. The planetary accretion. In the surrounding disk, dust and gas particles collided and stuck together, gradually growing into larger and larger bodies called planetesimals. Planetary accretion. Planet formation. Over millions of years, planetesimals continued to collide and accrete, excrete, eventually forming the planets, moons, asteroids, and other bodies of the solar system. The solar system includes the Sun and planets formed approximately 4.6 billion years ago from a massive cloud of gas and dust called the solar nebula, likely triggered by a supernova shockwave within the Sun forming in the center and planets coalescing in a surrounding disk. Summarize. The nebular hypothesis, which describes this process, is the most widely accepted model for the formation of our solar system. It explains the observed characteristics of the solar system, such as the orbital paths of planets, the distribution of mass, and the composition of different bodies. So far, we discussed about the formation of the solar system. We have that. Please subscribe our YouTube channel.